My background is I have a master's in experimental physics, and I studied ice. Preferred crystal orientation of freshwater ice under different freezing conditions. So for that work, I had a 1,000-liter tank in a cold room that was growing ice under different conditions, and then spent hundreds of hours in that cold room analyzing it. And then my PhD work was complex systems dynamics, and I developed a model that looked at the stable states of the Arctic sea ice cover. So there's been a lot of talk about there being a tipping point where the Arctic sea ice is fairly suddenly going to disappear. So I built a model to study that and look at what the actual stable states are for that system. And
so what are your predictions?
I don't make predictions. That's I leave that to others that are more bold.
Well, what does the model say?
Okay, so the model says that there is no clear-cut tipping point. There's a difference between the summer ice extent and how that'll behave and the winter ice extent. And the summer ice extent is exactly what we've also been seeing in the data, is we're seeing the sea ice recede further north every year, essentially, on average, while the winter ice extent remains the same. So the ice comes back to the same kind of latitude every year, but it's much thinner. And I, with this model, I developed a marker that would show this kind of regime change. And with the model, you can run hundreds of years of data and then force it whichever way you need. And I found this marker in my data, and then I looked for the same marker in the satellite record for the sea ice cover over the last 30 years. And if you look at the last 8 years, that same marker is there. So it correlates really well and says, yeah, we have undergone a regime change. It's not going to happen as people have predicted, that just suddenly the whole ice cover is going to disappear. It'll just change from a lot of multi-year ice to a lot of first-year sea ice.